So in the first two discussions, you learned that how to write neural networks on a set. You saw coding snippets on that. And if you are interested about JET, it's good to read this paper, which I also cited in my talk. This was by J.C. Thaler and company. So you look at the formula, which is called PFN, which they said particle flow network, but essentially it's a deep set. Because if Pi were the four momentums of the particle inside the jet, and phi and f are neural networks, two pieces of neural networks, then the output, you give input a jet and the output is a permutation invariant latent space representation of the jet. Okay. This you learned how to code up. You have all the code snippets. What I didn't put in my notebook is how to write energy flow network, where you can think of the energy flow network is given, what is Zi is given, right? So you can take Pi hat in this formula is a stack of the d eta and d phi of the individual particles, and use Zi to be the pt of the particle. I want you to code as a part of hands-on exercise this energy flow network. Now, we will start with some hints, etc., how to do it, but ultimately you have to do it. When we went through the notebook, remember we had formula written of how a permutation equivariant layer should look like, and then we summed up over all the points in the set to make a permutation invariant function. This is just that. So, but each of the nodes are weighted by the transverse momentum of the particle itself. So it's a very minor change to what you already have experienced. You have to code up this energy flow network. Now, if you can code it on your computer, it will be good. You fork the GitHub, and once you have done the coding, put it in your fork of the GitHub and put the link on the Slack so that each of us can go through your piece of code and have a look whether you're on the right direction. And let's say you want to regress the energy flow network to predict the soft drop mass. So putting these two side by side, you had a representation of a deep set, right? And in this language, you had two layers. One was let's go to the deep set layer. One has a capital gamma and one is the capital lambda. So, where is this? So if you have a set Pi, you can, using the same definition, you can do a gamma on sum over I from 1 to m lambda on Pi. How it should be done? Almost everything is there, but be careful that instead of equivariant, this is invariant. Now what we are asking you to do is that think of Pi hat is the vector of delta eta I and delta phi I. Maybe I should rub a few part of this. So it's a two-dimensional vector for each particle, which is Pi hat. And then you form a neural network layer, which is permutation invariant layer, according to that formula, which should be the same gamma PTI and lambda of pi hat, and then there is a sum over all the particles inside a jet. So following the same, almost everything same, you have to make very small modification to this layer structure, but you have to code up this function. This is your first task. If you followed what we did, it should be like less than 5 minutes job, but it won't be 5 minutes for everyone, and we want to do it with you so that you really understand by implementing of your own what is going on. This will be your first task. The second task, but this is all about just defining the layer. But that's not the full training. The training was, we had a data loader. Remember, here all the particle features, etc. were there. But when we did a batching, we did the jet and just the label because we had a classification task in hand. But here I want you to use the soft drop mass, the SD mass as the target, and you will do a regression problem. Okay, so you will have a jet, you will feed it to a neural network like this, and it should give output the soft drop mass. So you have to do a regression task. So you have to make sure that this piece of create batch returns you the soft drop mass. And once you do it, you will do a training using mean squared error loss or L1 loss kind of thing. So how much training performance you reach is not the point of this task. It's just to familiarize yourself how to code, and given a little modification on a network on top of what you have learned from the first session, you should feel confident that you can code that up yourself. Okay, so is the task clear, what has been asked? If not, before starting any coding, ask that if what has been asked to do is not clear to you. Let's again, this you have, so already you learned that a jet can be represented by a point cloud. That is clear. What it means is that in a set, each and every elements of a jet, the points, had some features sitting on it. There is an already available code how to compute those features, etc. Now we are asking you, write down a neural network layer which will have the following feed forward property. You don't need all pieces of informations which were sitting on the nodes. You just need 3 information. The PT of the particle, the delta eta and delta phi. Very simple task. Not all those n number of features which were shown in the code. Each particle has a PT, delta eta computed with respect to the central jet axis, and delta phi. This information is clear. So all these particles have this number. Construct a 2D vector, call it pi hat, which will be just delta eta I, delta phi I. This is for the ith particle, for all particles inside the jet. Okay, and then you form the corresponding neural network. You will have one piece of neural network gamma, a function. Then there will be a permutation invariant sum run from 1 to say m, PTI, and then there will be a lambda which will take into this pi hat. The particle had 3 numbers. The first, this angular dimensionless numbers should be processed by a neural network block, scaled up by the transverse momentum of the particle, and just sum over all the particles. This part is already permutation invariant because there has been a sum, and then pass the whole output to another piece of simple neural network layer, gamma. You have to code this up. And once you code this up, give it some your favorite name, your PFN layer, whatever. So this is one layer, and then you will stack few these layers. This will be an output. First of all, remember the task is to identify a mass of the jet, right? So you don't apply something like a softmax activation, nothing. The output number should be one number, not probabilities or something. So one number will be output. The target is a mass, and then you can compute a mean square distance or L1 distance, whatever is your favorite. And then you will optimize this function. You will train this neural network. This is the task. So almost all the code is in your hand. The skeleton is there. You have to make very small modification, but just code it up. Okay? Start. And any doubt, this is not your exam. Just say where you're stuck, what you're thinking. Let's do it together. You can open a new piece of notebook, copy paste these pieces of codes, and when you're done, you can just put it in your fork of GitHub and put a public link. So by the way, if you have any question, Vishal is there to help you out. I'm here. Okay, maybe what I can do is to take it on a stick and surround it. Okay. So there is already a stick available. Please circulate it.
But you can always proliferate and exponentially circulate, right?
Parallel processing.
You already have. Oh, data. Who has data? You have copy from him and circulate.
No, that root file of the jet. If you have that root file, please share with your friend. Anyone having any doubt, please let us know. No, next session is again another like hands-on introduction to graph networks. Yes. Who needs the data file? The root file? Who is missing that? Okay. There are large blocks there. Please copy it.